Hello everyone, welcome to Biswadeb classes. In today's class, I'm going to start a very important topic on complex number, which is modulus and amplitude of a complex number. I have seen that many students have so many doubts on modulus and amplitude of complex number. So in this video, I shall explain in shortcut technique and by using concept how you can find modulus and amplitude easily in exam. Okay, so watch this video thoroughly to understand the concept on modulus and amplitude. Okay, so before going to discuss modulus and amplitude, at first I shall explain geometric representation of complex number. What is geometric representation of complex number? Let z is equal to x plus iy, or let it be z is equal to a plus ib be a complex number. As we know, my A is called real part and my B is called imaginary part. Okay, we know this from our class 11 course. So, how we can represent this entire thing graphically? See that in my x and y axis, this x axis is called real axis, real, and this y axis is called imaginary axis. Okay. So what is x-axis? X-axis is basically real axis and y-axis is imaginary axis. So this A is basically my real part and B is basically my imaginary part. So see that suppose this distance is A and suppose this distance is B. In that case, this point will be my A, B. And this is my geometric representation of complex number. Okay. So always remember my x-axis is real axis and my y-axis is imaginary axis. In that case, this a, b, this will be my representation of this complex number, and this can also be written as a plus ib. For example, suppose a complex number is given as -1 plus I. So if we compare, this is my real part a equal to -1. My imaginary part b is equal to +1. So if we represent this entire thing in coordinate axis, then see that my a equal to -1. So here my a equal to -1. This distance is my -1, and my this distance, say this is my +1. So this will be my -1, 1, or in short -1. Or in short, -1 plus I. So this is called geometric representation of a complex number. So this concept is very helpful for us to understand the concept of modulus and amplitude. Okay. In my today's class, my target is to explain you everything from modulus and amplitude. And in my next video, I shall explain some important properties of modulus and amplitude and some very important questions from modulus and amplitude for all universities. Okay, so just watch this video thoroughly to understand the concept. So we have explained what is my complex number z is equal to a plus ib and this geometric representation. Now with the help of this, now we can explain modulus and amplitude. Okay. As we know, my a, b, that means a plus ib, this is simply a point P. So this distance is basically my a, and this distance is basically my b. And suppose that theta is the angle. Theta is the angle between what? Theta is the angle between x-axis and OP. O is my origin and P is my point. So this OP makes an angle theta with x-axis. Okay. In that case, this R is equal to modulus of Z. It is denoted by mod Z. This is basically a distance between origin and the point P. Is called modulus, and easily we can see that by Pythagoras theorem. My Pythagoras theorem says my R square will be a square plus b square, right? My R square will be a square plus b square. So my R will be root of r square plus b square as given here. So this r is equal to mod z is basically a distance between origin and the point. So what is the geometric interpretation of modulus? Modulus means distance between origin and the point P. It is denoted by mod z. Okay. Now coming to the altitude part. Now, as we see that theta is the angle between axis and this OP. Okay. This theta is basically called amplitude. All the values of theta is called amplitude, but it must satisfy a condition. What is the condition? See that from this diagram and by using basic concept of trigonometry, see that we can write A by R. How we can write A by R? See that A is my base and R is my hypotenuse. Okay. And we know base by hypotenuse is basically cos theta. We know this is a very basic concept on trigonometry. Okay. So base by hypotenuse is called cos theta, and this implies my A means real part. My real part will be R cos theta. Similarly, see that what is B by A? See that B is my perpendicular and R is my hypotenuse. So perpendicular by hypotenuse is called sine theta. That means my B is equal to R sine theta. So these are very, very important equations. This is called polar representation. Polar representation. This is a part of geometry. Okay. So A equal to R cos theta, B equal to R sine theta. These are the equations. So my theta, all the values of theta that satisfies these two equations is called amplitude. There can be so many values of theta that can satisfy this equation. All these values are said to be my amplitude. Okay. There can be so many values that can satisfy this equation. Okay. And I again repeat, if you want to get a deep concept on this topic, go through my video, Allied Angle. I have prepared a video, Allied Angle, to understand this concept clearly. Okay, I shall upload the link of this video in description box. Okay, so this video will be very, very helpful for you, Allied Angle. So there can be so many values of theta that satisfy these two equations. All these values are called my amplitude. Okay. Now see that suppose alpha is a value of theta satisfying the above relation. I'm giving you an example. Suppose my R is 1. Suppose my R is 1. And suppose my A is equal to 1 by root 2 to understand this. And suppose my B equal to again 1 by root 2. Okay, let's assume this distance is 1. My A is equal to 1 by root 2 and my B equal to also 1 by root 2. In that case, we are getting what? In that case, we are getting my cos theta from this equation. Cos theta is equal to my R is 1. Cos theta is equal to 1 by root 2. And sine theta is what? Sine theta is also 1 by root 2. Giving you tan theta. We know that sine by cos equal to tan. My tan theta is 1. See that. Now to understand the concept is, okay, up to this we understand what is my amplitude. This theta is amplitude that satisfies these two equations, A equal to R cos theta, B equal to R sine theta. There can be so many values like this. Okay, I'm giving you an example. By taking R equal to 1, my A equal to 1 by root 2, my B equal to 1 by root 2. In that case, my cos theta and sine theta become this. So my tan theta will be 1. Now tan theta will be 1. Now it's a very, very important thing. See that tan theta equal to 1. There can be so many values of theta that satisfies this equation. For example, tan theta equal to 1 implies theta equal to pi by 4. So that is my one value of theta. That is my amplitude. But that is not the unique value of theta. There can be many more. I'm giving you the example. Now, if see that tan 2 pi plus pi by 4 is also tan pi by 4 is equal to 1. See that. I again repeat, for this you have to watch my video allied angle. If you watch that video, you can easily understand this concept. Okay? Easy and shortcut way. In easy and shortcut way, I have explained this allied angle. This is very, very helpful. So my tan theta equal to 1, my theta equal to pi by 4. So there is one value of theta, there is my amplitude, but there is not the unique value of theta. See that tan 2 pi plus pi by 4 is also tan pi by 4, which is equal to 1. That means my another value of theta will be 2 pi plus pi by 4. That means 9 pi by 4. And so on. Then 2 into 2 pi plus pi by 4. That will be again tan pi by 4. Tan 2 into 2 pi plus pi by 4. This will be again tan pi by 4. So my another value of theta is this. So we are getting so many values of theta. And all these values are satisfying this equation. This means this. Okay? So very important concept. So this is my amplitude, theta equal to pi by 4. This is my amplitude. This is my amplitude. All are amplitude. But that makes us a very difficult thing for us. Okay? That makes a very difficult thing for us. Because we have to take one value of theta, not all these values. Okay? Now coming to the point, see that, go through this example. If alpha is a value of theta satisfying above relation, suppose my alpha is pi by 4. See that. Okay, very easy language I am explaining you. Suppose my theta equal to alpha is equal to pi by 4. Just go to this example. So this is my amplitude. So my another value of amplitude will be what? Alpha plus 2 into pi. See that? Alpha plus 2 pi. It is my another value of amplitude. So if we put n equal to 1, say that if we put n equal to 1, my another value of amplitude will be alpha plus 2 pi. So compare this. Say that I again repeat here in this example, my first value of theta become pi by 4. And we have denoted this by alpha. So if this is my amplitude, my another value of amplitude is what? My another value of amplitude is 2 pi plus pi by 4. So see that if we put n equal to 1, my another value of amplitude will be alpha plus 2 pi. That means pi by 4 plus 2 pi. As we obtained here. Then put n equal to 2. My another value of amplitude will be alpha plus 2 into 2 pi, which is this. This is my alpha plus 2 into 2 pi. Okay? I'm giving you depth concept of amplitude that no one will explain you. Okay? That no one will explain you. In depth concept. Okay? We shall learn amplitude. So this is my, so all the values are my amplitude. That is why it is written that if alpha is a value of theta, satisfying the above relation, this is my relation. Satisfying the above relation, then argument or amplitude of z, argument or amplitude can be written as alpha plus 2n pi. Okay? That means alpha is if alpha is my amplitude, if we put n equal to 1, alpha plus 2 pi is also my amplitude. Alpha plus 2 into 2 pi is also my amplitude. I have explained this by means of this example. Okay? See that. If you have any doubt, just text me. Okay? I shall again explain it. Okay? Just comment in my description. Okay? In comment box. I shall explain you. So see that all these values are amplitude. So this is my concept of amplitude. This is called amplitude of a complex number. So amplitude may not be unique. There can be infinite number of amplitude. Just go through this example. But sometimes we need some unique value of theta that will satisfy these conditions. Okay. Or another in another way, we want to find unique value of theta that satisfies this condition, okay, and lies between minus pi to plus pi. Why minus pi to plus pi? Because minus pi to plus pi, their length is 2 pi. A complete circle is length 0 to 2 pi. We know this. So what is the theory? So this is my concept of amplitude. Now coming to the another part, principal amplitude. What is principal amplitude? As we have seen that there are so many values of amplitude, alpha plus 2 and pi, they are in this form. If we need a unique value that lies between minus pi to plus pi, unique value of theta that will lie between minus pi and plus pi, that value of theta is said to be principal amplitude. And the main thing is, by amplitude, we always take principal amplitude. Okay? Amplitude always আমরা principal amplitude ke consider করব. We shall always consider principal amplitude. And it must lie between minus pi and plus pi. Why minus pi and plus pi? Because between minus pi and plus pi, the length is 2 pi. And 2 pi is length of a complete circle. Okay? That is why we shall take that value of theta lies between minus pi and plus pi. That is said to be principal amplitude. That means there can be so many values of theta, but we shall take the value of theta between minus pi and plus pi. That value of theta is said to be principal amplitude. And I again repeat, amplitude means always we take principal amplitude. Okay. This is my concept of principal amplitude. Okay, that means you can't consider all the values of theta. If your value of theta lies outside this range, we can't take it as an amplitude. Okay, because we always consider principal amplitude. So how we can find this value? I shall explain this by the means of an example. Okay, now take an example. And if you like this video, don't forget to like and comment. So in summary, my modulus is root over a square plus b square, which is the distance between origin and the point P. And my amplitude is the angle between axis and OP, which is denoted by theta, and it must satisfy these two equations, A equal to r cos theta, B equal to r sin theta. Okay, and suppose there is a particular value, alpha is a particular value that satisfies these two equations, then my amplitude can be obtained as alpha plus 2 into n into pi. These are my values of argument or amplitude. So, by the means of an example, I have explained this. And finally, we shall not consider all these values of theta. We shall consider the value of theta that lie between minus pi and pi. And that value will be my principal amplitude. Okay? We shall not going to consider all the values of theta. We shall consider only that value lies in minus pi to pi. Now we consider some examples. And after that, I shall give you a shortcut technique for exam purpose. Okay? Just go through this video. I can ensure you will not have any doubt after watching this video from amplitude and modulus part. Still, if you have, then don't forget to comment. Okay, I shall definitely explain in my next video. My next video will be on properties of modulus and amplitude and some problems on modulus and amplitude. But in this video, we shall understand the concept of modulus and amplitude. Okay. So my first question, find the modulus and amplitude of minus 1 plus I. So here my Z is minus 1 plus I. So here my A is, real part is minus 1, my imaginary part is plus 1. Okay. So as we know, my A is r cos theta, my B is r sine theta. So my r cos theta is -1, my r sine theta equal to +1. Now my target is to find r. We know that r equal to root over a square plus b square is modulus. Modulus is very, very easy. Modulus is equal to, we know, it is r, which is root over a square plus b square. That means root 2. So this length is basically distance between origin and the point P. So this is my modulus. Modulus is very, very easy. Now coming to the main part, what is my amplitude? So my r become root 2. Therefore, from this equation, put r equal to root 2. This is giving you cos theta equal to -1 by root 2. Similarly, put r equal to root 2 here. My sine theta will be simply 1 by root 2. So r cos theta, so my cos theta is -1 by root 2. My sine theta is +1 by root 2. Okay. So if we consider this coordinate axis, see that my cos theta is negative. Cos theta negative? কোথায় হবে cos theta negative? In which quadrant my cos theta is negative? Cos theta is negative in second quadrant and in third quadrant. So in these two quadrants, my cos theta becomes negative. And my sine theta is positive. In which quadrant my sine theta is positive? Sine theta is positive in first quadrant and in second quadrant. Okay? In these two quadrants, my sine theta is positive. So see that they coincide at second quadrant. That means we have to consider second quadrant. It's a very, very important trick. See that. My cos theta is negative here and here. My sine theta is positive here and here. They coincide with each other. That means they intersect. They intersect in second quadrant. So at first we shall select second quadrant. Okay? তাহলে আমরা কাকে সিলেক্ট করছি? আমরা সেকেন্ড কোয়াড্রেন্টটাকে আমরা সিলেক্ট করলাম. We select second quadrant. Okay? Now see that my tan theta is what? My tan theta is 1 by root sine theta by cos theta. তাই না? Tan theta কি হবে? Sin theta by cos theta হয়তো? So sin theta is this, my cos theta is this, giving you -1. So my tan theta becomes -1. This means my tan theta is minus of tan pi by 4. Because we know 1 is tan pi by 4. Now go to my video of allied angle. Now see that we have to consider the second quadrant and my angle is pi by 4. So how we can do that? We have to consider second quadrant and my angle is pi by 4. So we can write tan theta is equal to tan pi, say that, pi minus pi by 4. Because we know pi minus pi by 4 giving you in second quadrant. Okay? And from this, my theta becomes 3 pi by 4. And this is the unit value that lies between -5 to +5. My -5 means -180 to +180. Obviously, 3 pi by 4 lies between this. That means this is my principal amplitude. Okay? Say that. This is a shortcut technique. Okay? 3 pi by 4 definitely lies between this. But there is not the unique value of the amplitude. There can be so many value of the amplitude. My another value, this is my alpha. If you find some more values of amplitude, say that this is my alpha that we have discussed here. This is my alpha. See that this is my alpha. Alpha is the value of theta. That value is 3 pi by 4. So if you find some more value of amplitude, my another value of amplitude will be alpha plus 2n pi. That means put n equal to 1. If we put n equal to 1, my another value of amplitude will be alpha plus 2 pi. Here my alpha is 3 pi by 4. My another value of amplitude will be alpha plus 4 pi and so on. But we shall not going to consider all this because my principal amplitude always lies between this range. you can see that all these values are outside this range, because this value 3 pi by 4 plus 2 pi is totally outside this range, and this value is again outside this range, minus 182 plus 180. So we are not going to consider all this. So this is my amplitude. Okay. So we are not going to consider all these values. We shall consider only this value as my principal amplitude. Okay. Now there is a shortcut technique. There's a shortcut technique of finding amplitude. Shortcut. It is only for competitive exam purpose. Please don't apply this shortcut technique in university exam questions, because in that case your marks will be deducted. Shortcut technique is what? Suppose A is greater than 0, B is greater than 0. Then my amplitude will be theta. Okay, this shortcut technique. Okay, this shortcut technique has been prepared by considering the fact that my principal amplitude must lie between minus pi and plus pi. Okay. এর উপর বেস করে বানানো হয়েছে শর্টকাট টেকনিকটাকে. ওকে, সো this shortcut technique is also helpful, but it is but please don't apply this in exam paper. You can apply this in competitive exam. If my A less than 0, B greater than 0, my amplitude will be pi minus theta. If A less than 0, B less than 0, my amplitude of Z is equal to theta minus pi. My A greater than 0, my B less than 0, my amplitude will be minus theta. Okay. So how you can apply the shortcut technique? See that in this question, here my A is minus 1, my B is 1. So see that in my previous question, my A is minus 1 and my B was 1. So my A is negative, my B is positive. That means my case 2. Then see that my A is negative, my B is positive. So this is my case 2. This corresponds to case 2. So in that case, what is my amplitude? My amplitude is pi minus theta. Okay, my amplitude will be pi minus theta. Now see that. Now see that in this question, my theta was what? My theta was pi by 4. My theta was pi by 4. Fine? Say that my theta was pi by 4. So if we apply this, pi minus put theta equal to pi by 4. So 3 pi by 4 is my amplitude. See that my 3 pi by 4 as we obtain here. This is a shortcut technique. It's a very easy technique. Coming to the next question, this question is very, very important. You have to find out modulus and amplitude of minus 1 minus I. How you can find this? See that here my A equal to minus 1, my B equal to minus 1. Now that question is quite difficult. So my R cos theta is minus 1. My R sin theta will be minus 1. My R cos theta is minus 1. My R sin theta will be minus 1. So as we know, my modulus R will be root over a square plus a square. Root over my A is minus 1. My B is 1, giving you again root 2. Okay. So my again R is my root 2. Putting it here. Root 2 cos theta equal to minus 1 means cos theta equal to minus 1 by root 2. And similarly, my sin theta will be minus 1 by root 2. So my cos theta is minus 1 by root 2. My sin theta is also minus 1 by root 2. Okay. So now what? Now we have to decide the quadrant in which they lie. See that my cos theta is negative. Cos theta is negative here and here. My sin theta is negative. My sin theta is negative here and here. Okay. So they coincide, they intersect at this quadrant. So we shall select third quadrant. So we are selecting the third quadrant. Because cos theta negative and sin theta negative, they coincide here at third quadrant. Okay. We are selecting third quadrant. Now we have to find out amplitude. Tan theta. My tan theta will be sin theta. by cos theta, giving you 1. Tan theta is equal to 1. That means my theta equal to, my tan theta is equal to 1, which is equal to tan pi by 4. But there is, now if we cancel, and if you say theta equal to pi by 4, you are wrong. Because see that my quadrant is third quadrant. So in third quadrant, how we can write tan pi by 4? In third quadrant, how we can write tan pi by 4? This will be tan pi plus pi by 4. Because remember, our quadrant is third quadrant. From this, if you cancel tan and if you say theta equal to pi by 4, you are wrong. Because theta equal to pi by 4 in first quadrant. Theta equal to pi by 4 is in first quadrant. But remember, our quadrant is third quadrant, where both cos theta and sin theta are negative. See that? In this approach, you can solve all the question of modulus and amplitude. Okay? So by tan theta, so third quadrant, we can write tan theta equal to tan pi plus pi by 4. I again repeat, for this, go to my allied angle video. And my theta become pi by 4. And this is my answer of this question. Done? No, रुको जरा, सबर तो करो. देखो, ऐसे नहीं होता है. Okay? रुको तो जरा, देखो. My theta become pi by 4. But our always target is to find principal amplitude. See that 5 pi by 4 does not belongs to this range. Why? Let us take pi equal to 180, as we know. And this will be 5 into 45. Yes. Okay, 5 into 45. And 5 into 45 is outside this range. That means this value is not my principal amplitude. Now, what? This is a big question. And students are getting confused at this stage. Okay, every time. So see that we are coming to third quadrant by moving in anti-clockwise direction like this, as we have done in almost all questions. But here, if we move in anti-clockwise direction like this, we are getting theta equal to 5 pi by 4. That is my only amplitude, not principal amplitude. Okay, because it does not lie in this range. Okay, because 5 into 45 does not belong to this interval. Then what we can do? Okay, the thing that we can do is we have to move clockwise direction and coming to here and coming in third quadrant. See that what we can do is we shall move in clockwise direction and coming to the third quadrant, because third quadrant is my ultimate destination. Okay, this is called negative. This is called negative co-terminal angle. Negative co-terminal angle. We have done this in our high secondary course, remember. This is called negative co-terminal angle. Okay, because in most of the cases we move in anti-clockwise direction. Okay, because but if we follow this process here, my answer is not belong to this range. In that case, in almost in all cases, what we shall do is to move in clockwise direction and coming to the third quadrant. This is my way. This is called negative co-terminal angle of an angle. I shall make a separate video on this. This is not the purpose of this video. Okay. In this video, we shall explain the modulus and amplitude. I shall prepare a video on negative co-terminal angle. Okay. So in that case, we have to move clockwise direction and must reach in third quadrant. So how we can do that? See, for negative co-terminal angle, the theory is if theta is my angle in anti-clockwise direction, theta is my angle in anti-clockwise direction, then if we move in clockwise direction, its negative co-terminal angle will be its negative co-terminal angle will be theta minus negative co-terminal angle. This will be theta minus multiple of 2 pi. Multiple of 2 pi. This is my concept of co-terminal angle. Theta minus a multiple of 2 pi. That means it can be 2 pi into 1. It can be 2 pi into 2. It can be 2 pi into 3. Why this theory comes? Because the total, okay, in a circle, the total angle is 360, means 2 pi. Okay, so I shall make a prepared video on this concept. Okay, so in this video, just remember, if theta is my angle in anti-clockwise direction, then if we move in clockwise direction, my angle will be theta minus multiple of 2 pi. So in this question, my angle was theta equal to 5 pi by 4, but that does not belongs to minus pi to plus pi. Then my amplitude will be theta. My theta is this minus 2 pi. We are taking multiple, that multiple as 1. Multiple of 2 pi. We are taking that multiple, basically my negative co-terminal angle. Okay, my negative co-terminal angle is equal to angle minus 2 pi into n. But n can be 1, n can be 2. Here we have taken theta is equal to 5 pi by 4 and my n equal to 1. So my answer becomes minus 3 pi by 4. You can see that this angle lies between minus pi and plus pi. So there is my amplitude in this question. And since this principal amplitude is notation is this small a and b, we shall write a in small letter. It's a standard notation. My amplitude becomes minus 3 pi by 4. Okay, if you take n equal to 2, my amplitude will be 5 pi by 4 minus, if you take n equal to 2, that will be 4 pi. Okay, see that. If you take n equal to 2, so, and in that case, this will be minus 9 pi, I guess. Okay, 5, 4. No, sorry, 11. Minus 11 pi by 4. But this value does not lie in minus pi to plus pi. If you take n equal to 2, my amplitude will be minus 11 pi by 4. But this value will not lie between minus pi and plus pi. So you can't consider this. So we always take n equal to 1 and my amplitude becomes this. So in shortcut, what is my shortcut theory? My shortcut theory is if this amplitude does not belongs to minus pi to plus pi, always consider its negative co-terminal angle, means move in clockwise direction, and this negative co-terminal angle will be theta minus 2 pi. Okay, theta minus 2 pi by putting n equal to 1. But this is the actual theory. I shall explain this in a separate video. And if we use the shortcut method, see that shortcut method, here my A is negative, my B is negative. Right? My A negative, by my B is also negative. In that case, the theory says what? The theory says if A and B are both negative, my amplitude will be theta minus pi. My amplitude will be theta minus pi. So here, if we apply this concept here, my theta is what? My theta is pi by 4. My shortcut technique. My theta is pi by 4. So my amplitude will be theta minus pi. See that we are getting the same answer. Only 1 second needed. But in university exam, go through this approach. Don't use this shortcut method. Okay? This is only for competitive exam purpose. So I hope You have understand all this concept from this lecture video. Still, if you have doubt, don't hesitate to ask me. And if you understand all this concept, take this as a homework. Find the modulus and amplitude of root 3 minus I and minus I. This is the homework question. Okay, so there is everything from this video. We shall again meet in my next video. Some properties on modulus and amplitude and some important questions. Till then, bye-bye.